Okay. Section 1.5, exponential notation. That's a fancy title, I guess. I mean, exponential is kind of a fancy word, maybe. I don't know if you think so. But essentially, we're just going to be doing something you might already be familiar with. Exponents. You know, raising something to a power and all that stuff. The string activity. If you miss class, we may or may not have actually done the string activity. It's very possible we didn't, so you might not be missing anything. And so here we go. 2 to the 0 power. And then 2 to the first power, 2 to the second power. That's how you say all this stuff. Getting kind of, I might as well show this real quick first. For your calculator, if you want to raise 2 to a power, there's this button, like the TP button or the caret button. This is the button, and it would be, on the left if you're using a calculator from my classroom. This button is very easy to find. It's in the left-hand column of the key, the keys, the buttons. And you would hit 2, and then this button. And if you wanted to raise 2 to the 5th power, you would hit 5 and then equal sign. But I actually might be getting a little bit ahead of myself. What does it mean to raise something to a power, right? Like 2 to the 2nd power. Let's actually do this one first. It might be good to do this one first, or one of these first. 2 to the 2nd power means you multiply this base times itself twice. Okay? So it's like 2 times 2 because the power was 2. 2 to the 3rd power means you do 2 times 2 times 2. Okay? 2 to the 4th power would be 2 times 2 times 2 times 2. And that would be, well, first of all, this would be 4. This would be 8. 2 times 2 times 2 would get you 8. And your calculator will take this and immediately tell you that the answer is 8. You don't need to type this into your calculator. You can just do 2 and then the TP button and then 3, enter to get 8. And then this ends up being 16. 2 to the 1st is just like 1 factor of 2. I know I'm using these fancy words already. And then do you know what 2 to the 0 power would be? Try your calculator really quick. 2 to the 0 power gets me 1. And then 2 to the 5th power would be 2 times 2 times 2 times 2 times 2. 5 of these. And your calculator would tell you what? 2 to the 5th power would get 32. Okay? Because, 2 times 2 gets 4, times 2 makes 8, 8 times 2 gets 16, times another 2 gets 32. The penny story, you might not be missing anything there. The folding paper activity, if you want the full experience, like if you missed class, grab a random piece of paper and see how many times you can fold it in half. Like hamburger style, like fold the paper in half, and then fold it in half again, hamburger style, and then again, hamburger style. And see how many times you can literally fold it in half before you really can't, you don't have the muscle or whatever to fold the piece of paper again. So if you want the full experience, pause the video now and do that. Alright, I don't know, maybe you were able to fold it 6 times, 7 times. I'm not sure exactly what the official record is, like when you literally shouldn't be able to fold the paper any more times. But here's a cool little, fact. If you could literally, physically fold the paper in half more times than what you're actually able to do. Here's a question, I guess. How many times would you fold the paper in half before the thickness was so thick that it was able to reach the moon, right? Let me kind of say that again in a different sort of way. You know, if you fold a piece of paper in half one time, it goes from being literally paper thin to like twice that after one fold. Like now it's twice whatever paper thin is, right? That's not very thick. Paper thin is obviously not very thick at all. It's very thin. And even if you double that with one fold, it's still not very thick at all. But if you fold it in half again, now it kind of doubled that. And if you fold it again, you've doubled that. And then you fold it again and you've doubled that. So by the time you folded it like 6 or 7 times, whatever you were actually able to do, it's actually pretty thick. Like you really, it's much thicker than paper thin now, right? Like the new thickness. Well, guess what? You know what? As I'm doing this video, I wish I had that information. But I think it's something like, if I had to guess, well, let's put it this way. What do you think it is? How many times, how many folds would it take until the thickness of your paper would be so thick that it would like reach the moon? I'm pretty sure it's less than 50. Less than 50. Anyway, if you want to look into that, Google it, or actually do the math, feel free. But let's actually move on, so this video is not an hour long. All right, here we go. Let's get some things down officially as like terminology. So I hope, because I think this is really just a review, right? All this exponent stuff. So when you have this, you say 4 to the 5th power. 4 to the 5th power, and this is what it means. It means you do 4 times 4 times 4 times 4 times 4, 5 of them. So it's like you have 5 factors of 4. 4 times 4 times 4 times 4 times 4. 1, 2, 3, 4, 5. This number is called, I probably already said the word earlier a few minutes ago, but what is this number called officially? It's called the exponent. And this number 4 right here is officially called what? It's called the base. Okay? So the exponent sits on a base, like the base of a statue or something. Okay? So this is what we call the base. This number right here is what we call the exponent, which means you do this mathematics. And I don't know what this is. It's kind of a big number. Who cares? Because here's what we're going to do. We're going to rewrite this multiplication in exponential notation. Now, again, fancy word, but basically we're going to write this using an exponent, and a base. And then we're going to identify the exponent and the base. So, not too tough when you know what's going on. Let's go purple. Donatello was my favorite Ninja Turtle when I was really, really young. Because he's the best Ninja Turtle. That's why. No argument. It's just the way it is. Anyway, so 6 would be the base, and the power would be, or the exponent, would be 4. Because 1, 2, 3, 4. So the exponent would be, oops. Let's do the base first. Sorry, psyched you out. There's the base. And there's the exponent right there, the 4. Okay? Over here, well, what's number 2? Number 2 is over here to the right. So 9 times 9 times 9 times 9. That would be, if I'm counting them correctly, the base, I'm just going to say it from here on out. I'm not going to write the words. Sue me. The base would be 9, that's the base, and the exponent would be how many factors there are? 7. So that's 9 to the 7th power. Yep. Okay, number 3. The base would be -5, and the power would be 3. But guess what, people? I'm going to put the base in the power. Okay? Or What did I just say? I'm going to put the base in parentheses, just like it says here, you know. But even if there were not parentheses up here around all of the negative 5s, I would you still need to understand that it's necessary for there to be parentheses here, because otherwise the power, okay, I'm going to write something down. Don't write it down. Don't write this down. Just look at this. If I only wrote that, guess what? This exponent would only apply to the 5, not this negative out here. You know, it would be this negative kind of chilling out in front, disconnected from everything, and we would only be raising the 5 to the third power. But look, it's negative 5 times negative 5 times negative 5. The negative is included in what's being raised to the third power. So parentheses are very, very important here. In 2018 anyway, I still have, and hopefully I always have this from here on out, my awesome green tattoo on the wall somewhere in my room. And that's why I have the green tattoo. Anyway, at this point in time I have the green tattoo on my wall. And so this would be the final answer, and the exponent is 3, and the base is negative 5. The exponent sits on the base like kind of the base of a statue. Over here, x times x, 3, 4, 5, 6 factors of x. And so the base is x and the exponent is 6. Expand and evaluate. Please read directions always. Let's go back to Donatello Purple. Expand means, you know, hey, you probably already realize what that means. Expand it out, you know, expand it, make it longer. But in math terms, writing it as 3 times 3 times 3 times 3 times 3, that's what expand means. Let me grab my calculator just to make sure I'm not going to make a stupid mistake. So 3 to the 5th power, because I should say this, so listen. Evaluate, that part is like part 2 of the directions, and it means like what is the value of all this? Like let's actually do it. So you're going to get 243 when you do 3 times 3 times 3 times 3 times 3, or just on your calculator do 3 caret 5, or 3 TP, whatever you want to call that button. 3 TP5, and you get 243. Number 2, expanding this would be, well, I don't think I'm going to have enough room on my screen. You might have the room on your paper, but I'm going to do it down here. Negative 3 times negative 3 times negative 3 times negative 3 times negative 3. So 1, 2, 3, 4, 5 of those factors. Again, like the negative is included. The negative is included. And so now it's time to evaluate that. And when you do that on your calculator, you're going to get negative 243. All right? Moving on to number 3, expanding it first. Okay? Expanding that means you write it. You have to literally write it out as like I'm doing. 3 times 3 times 3 times 3. And when you go to your calculator to evaluate, in other words, find the value, like I said, you're going to get 81. Over here, it'll be negative 3 times negative 3 times negative 3 times negative 3. And guess what? When you do that on your calculator, and guess what? You have to include the parentheses around the negative 3 if you're just doing this. Like negative 3, then the caret, and then 4, and then you hit enter. Okay? You got to have these parentheses. Really, 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 really important, because guess what the answer is? Positive 81. Because negative 3 is like something negative times something negative times something negative times something negative ends up with a positive answer. Okay, make sure you can get that on your calculator. All right, I think we're about done with. I think this is the last thing. So just a quick little, I don't know, neat little activity or just something kind of interesting. 10 to the 0 power. What is 10 to the 0 power? Turns out that it's 1. Okay. Here's a little spoiler alert, like some foreshadowing, I guess. Anything to the 0 power will get you 1. That's something that's going to be like something we're going to officially learn in a later section, in a later chapter, I think. Wait, no, this chapter. We're actually going to officially learn that in a later on in this chapter, that anything to the 0 power is just 1. Even like x to the 0 power is just going to be 1. Anyway, 10 to the first, that's 10. 10 to the second is 100. 10 to the third is 1,000. 10 to the fourth is 10,000. 10 to the fifth is 100,000. So do you see a pattern? I guess what would 10 to the n be? I know that's a weird question to ask because n is just a letter. It's a variable. But, look at the pattern. What's the pattern? So what would 10 to the whatever power be? And hopefully you're thinking that whatever this n is, it would be a 1 followed by that many zeros. So it'd be like a 1 followed by n zeros. So like whatever this would be, it would be like that many zeros following the 1. And here's something interesting. 10 to the 100 power. 10 to the 100 power. An insanely big number. I don't even know if the calculators can do this. Let's see here. 10 to the 100 power. Yeah, my calculator is even fancier than the calculators you're probably using. And I'm getting an overflow error because the number is so big. And it's so big, we just have a special name for it. It's called 1 Google. Crazy. And that's that. Whoa. I wonder how, I think it's probably Japanese or something. I wonder how that actually is said. But that's it for section 1.5.